State the intercepts and asymptotes of a rational function. Sketch the graph, plotting points, intercepts, asymptotes as dashed lines, correctly showing general shape with a smooth curve. All right. The first thing we want to do is take a look at this rational function in factored form. The numerator is factored x minus 6. The denominator factors as x minus 7 times x plus 1. Okay, the numerator equals 0 gives us the x-intercept. The denominator equals 0 gives us vertical asymptotes. In this case, no factors reduced. That's when you get a whole, and that decreases the number of x-intercepts and vertical asymptotes, but it increases the number of wholes. Okay, next up, a comparison of the leading terms in the numerator and denominator give us that we're dealing with degree 1 polynomial on top and degree 2 polynomial on the bottom. When the degree of the denominator is larger than the degree of the numerator, we get y equals 0 is the horizontal asymptote. If the degrees are equal, then you take the coefficients of the leading terms, make a fraction, and then y equals that value is the horizontal asymptote. And if the degree is larger in the numerator, you do long division, throwing away the remainder, and then y equals the quotient is the slant asymptote. Now, for the y-intercept, we let x equal 0. Plugging that in, we get negative 6 over negative 7 times 1, and we get 6/7. So we have the y-intercept as 0,6/7. So let's do a double check. State the intercepts. We have the intercepts. The asymptotes. We have the horizontal and vertical. Great. Now we're up to sketching the graph. The intercept 6, 0. 1, 2, 3. Let me establish the size of the scale of our graph, labeling the tick mark. So 6, 0 here, and 0 and 6/7 there. Definitely not enough information to graph. The asymptotes, x equals 7, vertical asymptote. Let's dash this line, and we can label it. I label on top or bottom. This will be x equals 7. And we also have negative 1. X equals negative 1 is a vertical asymptote. Let's sketch that as a dashed line and label it. And we have a horizontal asymptote at 0. Since 0, y equals 0 is the x-axis, it makes it difficult to draw a dashed line. So instead, I typically just dash the ends so I can tell. And this would be y equals 0, horizontal asymptote. Now, there's a couple of pieces of information that we're given, the intercepts. So I could probably sketch this part of the graph. I want to label these on the other side now that I see where the graph is. There's that side, and this side is going on up towards the asymptote. Make sure it continues to get closer. Now, why did I know that it actually crossed at 6 and not like bounce back up? It's because this x-intercept is multiplicity 1. Multiplicity 1 is where things cross, or they change sign from one side being positive to the other side being negative. Using that same type of analysis, The vertical asymptotes are multiplicity 1 as well. That means on each side of x equals 7, you'll see a different sign. On the left side, this graph is down. On the right side, this graph would be up. So we can get an idea of the shape of this side. There are no other values where y equals 0 except for positive 6. So there's no other x-intercepts to have that graph cross. Equivalently, our x equals -1, that factors multiplicity 1. So on one side, on the right side of it, it's positive. On the left side, it'll be negative. So if you understand the multiplicity, you can actually sketch this more. However, it would also be very safe just to plot values like what happened at -2. Plug in -2. What happened at like 6.5 to see if it actually crossed. What happens at 6.5? And on the right side, what happens at 8? Plug those values in. At -2, you'll see that it's negative. At 6.5, you'll see that it's negative. At 8, plug it in, you'll see that it's positive. That would have also been evidence on how this thing behaves around these intercepts and asymptotes. Okay, I hope this helps.